So, welcome back once again, and in continuing with our first lecture on the ray optics, okay, and where we discussed the convention, the sign convention. Now we discuss the mirror equation 1 upon v plus 1 upon u equal to 1 upon f, which I told you that according to this sign convention, whether the mirror is a concave mirror or a convex mirror, okay, if the proper signs are given to the object, the image, and the distances from the pole, which is the object distance, for example BP, which is called u, and b dash p dash, where the image of b is made at b dash, is called v. And of course, as you see that the rays are coming in this direction. So in this particular case, where we have all the three things, the focus, the u and the v, they are all having negative values, okay, because they are on this side of the pole. So let us define an image. So an image is a point at which the rays emanating from an object point, after reflection or refraction or reflection and refraction, finally either actually meet in the case of real images or appear to diverge from a point under consideration in the case of virtual image. We'll see when the image is real and when it is virtual. Well, between the image and the point of which it is an image, there is a point-to-point correspondence. Okay. So in ray optics, the image is formed can be formed, of course, by several rays, but some of the rays which are friendly to us, that are the following principles we use in the convenient choice of rays. Number one, a ray principal to the parallel axis, for example, after reflection it passes through the focus. A ray through the center of the mirror, center of curvature, it goes back, retraces the same path. And a ray through the focus, I have not shown this, but we can draw from here to the focus and then it will be reflected back parallel to the principal axis, which I can show to you as to how a ray is going like that. And then we can take, like here I have taken a ray to the pole of the mirror, that is reflected back according to I is equal to R. Of course, everywhere it is I is to R used, but here it is more obvious. So you can see I start with one ray here, and ray number 1, this is 1. There is ray number 2, which is coming to the pole and reflected back here, and the third one is the ray through the C, and which is reflected back. And you can see we require only 2 rays for crossing each other, and whatever point they cross appear to be coming from that point, and that gives the image. So here I have got an image of A at the point A dash. Now suppose I take another point here, then I'll get another image, another image, another image as we go from A to B. Okay, then we get the images over here, and therefore we can say that for this object AB will get an image A prime B prime. In this case it is an inverted image and its length also appear to be less than that of the object. So it happens we can draw other diagrams where I can show that if the object is kept over here, then the image will be a virtual image. So in this case we have the actual image for the points starting from A to B, and the image is A prime to B prime. Okay, so here we define these points as BP is equal to U, FP is equal to F, and B dash P is equal to B. We are not purposely taking over here the sign convention because we are dealing in geometry. Okay, we'll talk more about it. So now with the help of the ray diagram, okay, and the sign convention, we will establish the equation 1 upon V plus 1 upon U is equal to 1 upon F, where V, U and F are the image distance, the object distance and the focal length as measured from the pole P. Now you can see that A dash B dash F and FPM, this, okay, they are right angle triangles and they are similar, particularly when M is very close to P and MP is almost perpendicular to the CP, which is the principal axis. So I can write B dash A dash divided by PM, this one, as equal to this upon this, okay, and B dash F upon FP, okay. But this MP is equal to AB, okay, this ray number 1 being parallel to that. So I can write B prime A prime upon, instead of PM I can write BA is equal to B dash F upon FP as PM is equal to BA. Now APB, APB, this is angle I. This ray is coming onto the pole of the mirror and this is going like this. So this angle of incidence, angle of reflection, they are equal, so this angle is equal to this angle, okay. So that means the right triangles A dash B dash P and ABP, these are also similar. When they are similar, then I can write A prime B prime upon BA, B prime A prime upon BA is equal to B prime P upon BP, okay, the bases of the two. So now if we compare the two of them, then I can write this BF upon FP as BF upon FP, BF upon FP, right? So from here to here, this is equal to this distance minus this distance, yani B dash P minus FP upon FP. So this becomes equal to B dash P upon BP. What is that? B dash P upon BP here. Okay. Now this is an equation in which we can put the values by the sign convention. Okay. So BP is equal to minus U, and B dash P is equal to minus V, and FP is equal to minus F. So when I substitute all these things with the convention, so we get minus V plus F divided by minus F minus V upon minus U. So if I divide by minus sign, so this becomes V minus F upon F, and this becomes V upon U. So I can just divide by F here, then I get V upon F minus 1 is equal to V upon U. Okay. So now if I divide throughout by V, then I will get this as 1 upon F, and this as 1 upon V, and this as 1 upon U. So I will get this relation 1 upon F minus 1 upon V is equal to 1 upon U. Or I can write that 1 upon V plus 1 upon U is equal to 1 upon F. Okay. So we have been able to obtain this relationship, and a similar relationship will also exist for the convex mirror. And then the other thing is about the magnification. The magnification is this divided by this, okay, the heights, that I'll do shortly. So we obtain the formula 1 upon V plus 1 upon U is equal to 1 upon F, which is applicable to both the case of the concave lens as also convex lens, and you can see that. Okay. Now one more item is the magnification, which is defined as the size of the image upon size of the object. So I did show there h dash upon h. So that turns out to be equal to V upon U. As in that equation, if you see that B dash A dash upon BA is equal to B dash B over BP. Using the sign convention, I can write minus h dash upon h is equal to, because h dash is down, it is the real image, inverted, etc. And minus V upon minus U, so M becomes equal to h dash upon h is equal to minus V upon U. So this is the formula that we obtain. Now, I have drawn, in the last case, our object was beyond the center of curvature. You can draw the object being put at the center of curvature, then the image will be inverted and of the same size. You must draw that. I am not going to draw it. And if the object is put between the center of curvature and the focus, then a larger size image will be made beyond the center of curvature, and you must draw that. But I have just chosen to draw, with my difficulties that I have, okay, drawing these things. So I have drawn a case where the object is between the focus and the pole of the mirror, the concave mirror. And then you see, I have one of the rays which is coming parallel, and then it appears to go through, and that is reflected back like this through the focus. It must pass through the focus. And the second ray that I have drawn is the ray from A to P, and this is reflected back like this. When drawn backward, we find that they meet at the point A dash. So A dash is the image of A. And similarly, when we go from A to B like this, then I'll get the image from A dash to B dash. Okay? And so the image can be seen, the formula can be verified still, okay? And if you take numerical values, which are plenty are available in the textbooks, okay, you must solve at least 25 to 30 questions or more, practice. the formula this and the formula m is equal to this. Okay. Now here I have taken a convex mirror, and I have taken an object the size BA, which is naturally the center of curvature is here, the focus is halfway in between. So what we take is one parallel ray, which after reflection will appear to be coming from F like this, and another one from A to P, and I is equal to R, and then I get this line. And you can see that these two lines, they meet at this point, which you call A dash. So A dash becomes an image of A. Okay, this is erect, like the object, so is the image. It is erect and it is diminished in size, smaller in size. Like in this case, the image is, the virtual image that we are making for A dash is, the whole thing A dash B dash is erect, but its size is more than the size of the object. But in this case of this mirror, this object size becomes smaller. Okay, so this is the kind of mirror that we have in the rear glass, rear view glass of the automobiles. Okay. So in a way, I have, I think I have justified. I have drawn the diagrams, I have talked about the geometry, etc., and you must be able to draw these diagrams and solve these problems, taking the sign convention into account, that always draw the diagram so that your ray approaches from left to right, okay, like this case or like this case, and the object distance or the image distance or the focal length, they must be measured from point P. Okay, in the direction of the incident ray, for example, in this case, we take the PB dash as positive. In this case also PB dash is taken as positive. Okay, so that way be always satisfied, very vigilant about the sign convention, and then we are in that case a Raja Beta, yeah, Rani Bitiya, and we are able to solve all these problems with the help of a single formula, 1 upon D plus 1 upon U is equal to 1 upon F. Thank you very much for the day.